Hello, everyone. Thanks for joining our session. Today, we're going to talk about cloud-native security on mission-critical system, and we're gonna discuss the result of the study we conjointly did with Airbus. Let's jump into the agenda. So we're going to talk first about the context of this study. Then Michael will talk about the use case, why it was important for Airbus to have such a compliant environment. Then we're going to talk about the objective, the challenges that we faced during this study, and then up with some demo about the platform. So I'm Christophe Dorze. I work for SUSE for almost 8 years, based in France. I went through, I work as a senior solution architect in the embedded and OEM today. And I've been through DevOps, DevSecOps, and currently bringing this maturity into the OEM and embedded market.
Hello everyone, I'm Debouver and I've been at Airbus for 6 years now. I'm a senior cloud architect working on different projects for our end customers and everything related to data engineering and to cloud native environment. So I'll start by explaining what is our use case. So as I mentioned, I'm from Airbus Defense and Space, and in defense and space, in those sectors, security is really at core. So this is a pattern here that we respect for almost all our design. So we have, I would say, public or internet access on the left. This access is segregated thanks to a firewall, and we just access here through a demilitarized zone or DMZ, in which we are going to find some components in order to ensure the communication between the outside world and the business zone. But what is important here is that the business zone is really segregated from internet and does not access internet. This is not possible to access internet from this business zone in which we are deploying our business application. So what is our objective regarding our use case that I just presented? So first of all, we tend to use more and more the cloud native environment and Kubernetes because we came from managing 1 or 2 satellites, for instance, in the space systems, to now managing constellations of hundreds of satellites. So this is important to have flexibility and scalability, and this is why we need to use the cloud native ecosystem. This cloud native ecosystem is quite rich, but is harder to use without having internet connectivity. Another remark that we can do is that the cyber attacks have increased in the past few years, and we don't need to precise that in the defense and space sectors, we're seen as prime targets for the hackers. So we need to be able to use the cloud native ecosystem, we need to be able to secure it, and we don't have access to internet. So this is our challenge. For today, we're going to try to build a secured cloud native environment without having any internet connectivity, and that in half an hour that we have for our session. So Christophe, first, can you tell us what is a secured cloud native environment?
Yeah, thanks, Michael, for asking. So basically, a secure cloud native environment would be the combination of a different security apply at different layer. First, we're going to start with the operating system. We're going to harden the operating system in regard of certain compliance and standards. Then we're going to cover also the container orchestration layer, which is the Kubernetes cluster. We're going to secure it, reinforce this, and we will end up by securing also the runtime, the workload being containerized and running on top of that. To ensure this security, we're going to also cover the monitoring. How do we prove that the stack is fully secured and hardened? But first of all, how can we measure security? What is it about? Security, it's about confidentiality, integrity, and availability. Confidentiality, it's about being sure that the information are only disclosed to the ones that need to access this information. Integrity, it's ensuring that this information isn't altered, modified, or by any aspect by anyone that should not access to it, that the information is not corrupted, basically. And the availability, of course, it's ensuring that this information is accessible at the appropriate time. To measure the security, there is different aspect. Let's say you can be like the security officer of your company. You can ask for pen test. You can ask for risk management and all, or you can also rely on some standard and compliance that exist in the market. Different country, different law, but everyone go for the same target, which is proving that the whole architecture infrastructure is secured from for the outside. So let's say, for example, in France, we use the ANSI standard. It's quite common, and it's also quite similar to the one used in Germany, which is the BSI. United States would be more on the DISA stick by the Department of Defense, and so different standard for different country, but everyone targeting the same excellence in terms of security. The tools that we're going to use today would be the DISA, the DoD, known as STIG, for Security Technical Information Guide. It's basically the standards that you need to comply with if you want to interconnect with the Department of Defense of the United States. And the second one we're going to rely on, but because we don't want to interface with the Department of Defense, but it's just a good standard for improving your stack in terms of security. The second standard we're going to use is the CIS. It's a well-known standard, international also. It offers benchmark for assessing security, and there is a dedicated benchmark for Kubernetes, which is available in the Kubernetes community. So let's summarize what's our plan here. So first of all, we will have to build the top-down layer, which is the operating system first. How do we harden this without any internet connectivity? Second, we're going to stack on top of that the Kubernetes layer, which would be the container orchestration layer. We're going to harden this also. Then we're going to ensure that all of that is being secured by activating the monitoring. Then we're going to build also secured workload by securing the runtime. And at the end, also run the CIS benchmark to ensure that this workload and container orchestration level is secured and compliant to the CIS benchmark. So let's go. So how to build an hardened OS without internet? We're going to rely on a well-known product from SUSE, which is the SUSE Manager. I'm not going to talk about all the different options you will find in SUSE Manager, managing different kind of distribution and all. We're just going to focus on provisioning and management. Basically, on the provisioning side of SUSE Manager, you will have the possibility to have a local repository, which would be mandatory in an air-gap architecture. So basically, we're going to pull everything locally, and we'll be able to play our deployment scenario, installation, and lifecycle management locally without any internet access. We're going to also use the node provisioning so that we'll be able to provision SLES 15 STIG compliant node here in this architecture. And we're going to also use the management tool from SUSE Manager, the management module, which will be able to help us patching, doing mass update and patching on the different node. And also, we're going to leverage the OpenSCAP module of SUSE Manager so that we can address the auditing of the different PCs present in the stack. So let's talk about how we're going to then deploy Kubernetes on top of the secured OS. So the different components we're going to use here would be Rancher and a key 2. Rancher is the de facto tool known by the SRE, the site reliability engineer, to help them to ease the work of deploying and managing and administrate Kubernetes cluster. The RKE 2, that's the well-known evolution of RKE, which is now very focused on being compliant with the US federal government sector. It's going to help us to address this problematic. So basically we will have to create two different clusters. The first one would be the Rancher cluster, which will host the Rancher server and the UI from which we'll be able to provision and manage the other cluster. Other cluster would be the downstream cluster, known as the target cluster in this architecture, and would be also RT2 based. Yeah. So basically, the stack would be then on top of the operating system provisioned by the SUSE Manager. We will have the master, and with the container runtime, you recognize the different component of a Kubernetes master with the etcd, the control plane, the kube proxy, and the kubelet, of course. And we'll have also the worker with the kubelet and the kube proxy. On top of that, we will have later on the runtime, and Rancher will be deployed on top. How to deploy the Rancher server? There is a Helm template for that, and it's pretty straightforward. As you see, there's just one command line, and the different YAML would be then written. Automatically, a few minutes later, you would be able to access your Rancher UI and start administrating your cluster from Rancher server. How to activate the monitoring then? Thanks to Rancher, it's going to be pretty straightforward. The monitoring would be basically the vision. You will have a fancy graph using Grafana and all. We're going to show this a bit later. But we'll have the possibility to see like the full stack consumption, memory usage, and also health check of the full stack. How to deploy that? Very simple. You go in Rancher UI, you look for the marketplace. Inside the marketplace, there is a monitoring box. You click on, you follow the very already provisioned template, and a few minutes later, you'll be able to access the Grafana UI and see the health of your cluster.
So now we're going to see how to secure the runtime, or how to secure the runtime in order for the applications to run securely. So in order to understand what is needed in this scenario, we need to address 2 points. First of all, we need to control who deploys. So this is native to Kubernetes. So when someone or a service account wants to deploy a Kubernetes object within the Kubernetes cluster, it will address the API server. So the API will be handled by the API server, and the API server will do the authentication and authorization. In other words, control if the people or the service account that wants to deploy the object is first authenticated and has the correct authorization to do that. So this is native to any Kubernetes cluster you would deploy. And finally, we want to also be able to control what is deployed. So I will just give you an example. For instance, imagine that someone is deploying a Kubernetes workload as a daemon set. So this workload will be deployed on each node, and imagine that this workload has memory leak, for instance, or is a virus. We don't want that to be feasible. So we will need to control what is deployed, and for that, Kubernetes offers 2 ways of doing that. So when the authentication and the authorization is made, then we have what's called the mutating admission. So this will enable a mutation admission controller to update the object that is deployed and add some information. So for instance, it could be some security information, some certificates, for instance, or it could be some annotations or anything that you want to upgrade within your Kubernetes object. Then once the mutation is done in the Kubernetes object, the schema of the new Kubernetes object, of the mutated Kubernetes object, is then validating against a new schema. And once this is done, there's another admission controller that is used, which is called the validating admission. So the idea of the validating admission is to be able to add new rules about whether we should be able to deploy or not an object within Kubernetes cluster. And if the validation is okay, the object is then persisted within the etcd and is then deployed into the cluster. So how can we do that? We are going to use a component called Open Policy Agent, OPA, OPA Gatekeeper. So what is OPA? OPA is an admission controller, which means that it implements the webhooks that we've just seen earlier. And OPA comes with a library that we can upload and that we can apply to different namespaces. This library includes, for instance, the fact that we uh, make it mandatory to have HTTPS for ingresses, so prevent from being able to have HTTP and forced SSL. We have also another rule which is called uh, resource limits mandatory. So it means that we prevent from deploying any Kubernetes object without having the limitation on the resources. For instance, if we just get back to the example I just gave you, imagine we have a daemon set with this memory leak. So this way, this will be the admission controller will make it mandatory to have a limit on the memory, and if the memory is too high, Kubernetes will destroy the object, and this will prevent from having impact on other workloads working on these nodes. And we have also another important rule that is in place, which is the root user privilege mode and privilege escalation forbidden. So the idea is that when we are talking about containers, when you are root within a container, you are in fact running a process within the host operating system, which means that you can be easily root within the operating system. And if you are in privilege mode or with privilege escalation, you can be root as easy as it just take to run the sudo command. So we need to really to prevent that in order to secure our system. So in order to prevent a hacker to be able to run its own container in privilege and be root in the host operating system. You can find a lot of rules that are described here on these following links, that are rules given by the OPA community to be able to add some constraints on your Kubernetes cluster. So just to summarize, we've seen that we already deployed the operating system. We have deployed the Kubernetes cluster thanks to Rancher and RKE2. And now we have open policy agents that controls everything that is deployed under the runtime. And on top of that, we have monitoring that monitors every component of these parts. So just to see how to deploy the open policy agent gatekeeper. So it's the same as for the monitoring. It's pretty easy. You just have to go to the Rancher marketplace and find the OPA gatekeeper. Just click on it and just click on install. And a few minutes later, the pods are up and running within your cluster, and you can access a dedicated GUI within Rancher, which is called OPA Gatekeeper here, where you have two possibilities. The first one is to create new templates or upload new templates from the OPA Gatekeeper libraries, so in order to add new rules. And you also have a constraints page, which is here for applying constraints, applying those templates within namespaces. So now we've seen how to secure the runtime. We've secured the build, the build of Hardened OS. We've deployed the operating system. We've deployed Kubernetes on top of this operating system. We've activating the monitoring. We have secured the runtime, and now we need to make sure that this is secured. So for that, we're going to rely on the CIS benchmark. So how to deploy the CIS benchmark? This is as easy as for OPA and as for the monitoring. So as Christophe mentioned, Rancher really eases the life of the site reliability engineer. So you just have to connect to the Rancher GUI and go to the marketplace, select CIS benchmark, click on install, and yeah, a few minutes later you have security auditing enabled on your cluster. So now you have also, as for OPA Gatekeeper, you have a dedicated GUI which is integrated within the Rancher. And you just go to this GUI and just create a new CIS benchmark with the profile that you want to apply. So by default, you have different benchmark available for within Rancher, and you just click on create, and it will just run a CIS benchmark within your cluster. And as you can see here, our benchmark is now passed after having a fail. When you want to have security on Kubernetes, you need to have security at any time. Which means that even when you deploy applications, you still need to apply security, which is important. You need to have security all along the life cycle of your cluster. So now we can see that we've achieved all our challenge. So even the security benchmark is passed, but you can trust us, or what we can do is try to demonstrate it and just run a demo in order to prove to everyone here that yeah, we did really build a secure cloud native ecosystem. So now let's just move to the demo. All right, so let's go for the demo. So the idea is to ranch a CIS benchmark. For that, we are just going to connect to the Rancher GUI, and we have the dedicated GUI here integrated within the Rancher GUI, which is for the CIS benchmark. So as you can see, we have already run some CIS benchmark that we are going to see during the time that the CIS benchmark runs, because it can take some time. So first of all, I will create the benchmark, and I'll just select the profile harden. So as you can see, there are default profiles provided by Rancher. Here we haven't created our own profile, but this is also feasible to create your own profile. So let's go with the one dedicated to RKE2 and harden cluster, and let's just run. So in the meantime, I will show you the way we deploy the monitoring and the way we deploy the OPA gatekeeper. So it's pretty easy. So you just have to go to the marketplace, and you have default applications that you can deploy within your cluster. So in blue, those are the applications provided by Rancher, and in yellow, those are the applications provided by external suppliers. What is important here is that all the applications that you can see here can be deployed without having access to internet. So when you set up Rancher, you need to have your private registry, and you need to upload in your private registry all the images necessary to deploy those applications. The point is that you don't need to have access to internet. You can deploy in air-gapped mode pretty any applications you want here. So for instance, the monitoring, you just have to click on monitoring, and then you just click on install. Here it's already installed, so I can update it. I can do it also without having access to internet. So when I upgrade my Rancher, then I have a new version of monitoring, and I can update the monitoring as well. So once those applications are deployed, most of the time you have embedded a GUI within the Rancher GUI. So you have a single GUI to control all your clusters. So here, for instance, monitoring, here you can see that we have Prometheus. You can just have access. You can have access to some Prometheus information, and we can access also to Grafana in order to visualize the monitoring of our cluster. So let's just get back to our CIS benchmark, and now we can see that the test is passed. So we're going to be able to have a look at what has been done. So you have the detailed report here for the benchmark test. So here, for instance, you have all the tests that are passed, all the ones that are won, and all the ones that are passed. So as I mentioned earlier, sometimes we can have failed on our cluster, or even if you want to fix the one, it depends on the need you have on your company, and on the environment in which you are working. You can have the details. For instance, in this one, we can see that the test is run on station masters 1, 2, 3, and we can have the remediation that is explained here. So this is pretty easy to use, and you can build your own profiles. So that's kind of easy too. You have a GUI to do that, but you can also automate. So everything that you do in GUI here can be automated, of course. you can create your own profile. And what is important also is that if you don't want to run a test, to skip a test on certain environment, you can also do that. So that's all for the demo. So with this demo, we have validated that the overall cloud native ecosystem that we've built without having any internet connection is secured. So we have been able to do that pretty easily and pretty quickly thanks to the overall SUSE ecosystem. Starting from the operating system up to the Kubernetes cluster, using different tools like SUSE Manager, Rancher Kubernetes engine, and Rancher server. I would like to just take a few time to thank our partner from SUSE, and especially Christophe here. So thank you everyone, thank you Christophe, and thank you SUSE for helping us on this study and making it a real success. I will now let Christophe say a few words to conclude.
Thank you, Michael, and also thanks, great thanks to Airbus to have helped us improve our product jointly in this research for high security level and high quality in security from for hardening everything from the operating system till the workload. I would have loved to talk a bit more about the workload, but I know it's under NDA. I know there is confidentiality around, and I just don't want everyone to break my door or my window and just and take my laptop basically. So thanks for everyone who have attended this session, and wish you a great SUSECON. Have a nice day. Bye.
Thank you everyone. Bye.